So, thank you so much for your patience. You should hear me right now. So, we are also live on Facebook, YouTube, on my profile. We've been active as before. So, I'm really pleased to introduce this small frontal workshop we're gonna have talking about behavioral analytics and why it matters also for designers. I have a couple introductory slides to give you some of the context why it does matter, and then I'll leave the stage to my colleagues Andrea Rossi from Sherlock and Felix Obolka, which is a PhD student in computer science in Cambridge, University of Cambridge, of course, and Emanuele Rossi, which is machine learning researcher and co-founder at Lead the Future and Twitter, of course. So let me just get the slide on. So, okay. For those who weren't here, I'm going to give you a little bit of an introduction of what the World Disability Day is. It is an international event, more than 200 events celebrating second Thursday of November. It is about usability in terms of ISO standard, International Standard of Organization and Definition, which is effectiveness, efficiency, and satisfaction for people reaching their goals in some context. So it doesn't talk about digital, it doesn't talk about technology per se, it does talk about how people would reach their needs and their goals within a context. So this is pretty important to understand, especially their behaviors. And this is what we're going to talk about in a little bit. So if you do have a question also during this workshop, you can scan this QR code. The questions are going to be moderated, and we're going to collect them during the workshop. After the first part of introduction, it's going to be a little bit more introduction, so you can use it to ask us questions, even very nerdish one, because we do have some tech abilities in this session right now. So just to give you a little bit of a better understanding, we are talking about this. We're talking about that nobody should suffer or feel stupid using technology of any kind, or otherwise nobody would try to abuse technology, be it on purpose or unconsciously. So we talked about that in 2018 with a friend and colleague of ours, Vincenzo Di Maria. We should make the systems user-friendly in a way and abuser-unfriendly. We're gonna talk about that today in a little deeper way than before. So let me start with a small, almost apparently stupid story. This is actually a screenshot for a real life example of ghosting. You know, when you date someone and this someone at some point you had a good time and he or she, they disappear. At some point you message, you text with them, and they stopped answering at all. So we're talking about that kind of behavior that you can see it coming and take a decision after that. So even though we're not talking about cybersecurity, because of course behavioral analytics is not only about cybersecurity, we're talking about people having behaviors, and those behaviors drive their decision in a way. So in this particular example, probably one of the partner in the conversation decided that at some point Daniel wasn't so cool and he actually was ghosting her or him. We don't know, but it's totally the same. So this is the first example. You see the pattern, you stopped answering, and that's what I'm talking about. And I'm talking about this famous man. So Catherine Hepburn receiving an "I love you," and you have the double blue check of WhatsApp. She watched that. She sees the message, but she didn't answer. That is also a pattern. Another pattern, which is a little bit more into the topic, nearer to us, they are so-called AI bots, like customer satisfaction bots or customer-centered answering machine, let's say. So in this particular example, you can see that it is not so smart to see that Mr. John West was trying to troll him, or it, actually, the bot, telling that the email was john@example.com. Probably was trying to make fun of the bot, probably was doing some of the adversarial attack to see if it's gonna break, or just probably he had some time to spare and wanted to do that. But at some point, when you interact with a conversational agent, be it trained with AI or not, we'll understand that on the other side, there is a machine, because it's weirdly out of context what it says, or maybe it's just not the answer you expected to have from a human being. My way of testing this kind of bots usually is to ask them to do a simple calculation, like a multiplication or a sum, to see if the opponent, maybe a spam bot from Instagram or whatever, it is actually a human being, or just a way to do some phishing. And that's another example. There are plenty of examples that I shared also in the very first presentation. For instance, I was talking about the analysis of behavior of people going home at a central time of the day in a certain car or way of transportation, mean of transportation. Well, so when you start analyzing behavior of people, you can try to guess what is going on, or better, if everything is okay for the health of the system, for the health of the people, and so on. So this is pretty much what I'm talking about. And funny enough, I received one of these phishing text messages even today when I was driving here to the conference that told me that as a client I should have tapped or clicked a link to renew my credential of a bank that I didn't have my account into, which is fun. They try to use that, but this is the simplest probably way of taking advantage of users, and you as a user could analyze this as a behavior which is actually a little malicious on your side. So my point about that is that we are talking about this, and we're trying to challenge you guys in the future weeks, in a couple of weeks from now, with a game. You know that this is a frame from a very famous movie, which is actually the story of Alan Turing, the father of information science and so on. And he actually set it up called as the imitation game. The imitation game is something that he wanted to put up to understand the conversation happening between a human being and another entity, would be between a human and a human, or a human and a machine. So the human should pose 3 questions, and when the opponent answer, he needs to understand the human being, whether it is a machine or whether it is actually a human being answering. So we're setting this up. In the next 2 weeks, we're going to send you an email as a participant of this conference with a link of a game. We set it up together with a partner. A user board with a technical partner of ours helped us giving the platform we're going to use. And it's a particularly interesting one because it is a bot that actually is powered by AI. You can train, but at some point, the bot could also be escalated to a human being. So you actually need to understand, and you will need to understand whether you're talking with a machine or a human being, and we're going to collect these answers. The theory beneath that, it's mostly about behavioral analytics, system health, and all the things that my smarter colleague than me are going to talk about in a little while. So I'm going to pass the mic and add to the stream to Andrea. And sorry, I removed it. Andrea, yeah, awesome. Whose slide we're gonna start with? Andreas, right?
No, Felix.
Felix, awesome. So let me introduce Felix. It's been introduced by Andrea to me. I didn't know him, but I have a couple of calls with him, and there's really smart people. We're gonna talk a little bit about machine learning basics because, of course, we're talking about artificial intelligence because it's convenient and it's easier to understand. But let's start to the real basics, talking about what machine learning is. So Felix, the stage is yours.
Right. Thank you very much, Carlo, for the introduction. And yeah, as Carlo said, before we can look into more details of how design and machine learning play together, we need some of the basics of machine learning. Now you might be wondering, why is that necessary? Because as as designers, you probably won't be designing machine learning algorithms yourself at some point. But it's a bit like driving a car, right? So when you're driving a car, you don't need to know anything about the engine itself. You don't need to fix the engine, hopefully. But it's still good to have sort of a rough understanding of what is going on, because then you can sort of account for sort of some uncertainty. Something is going wrong, then you can sort of you know roughly what's going on. And that's the same with machine learning. So if you ever work with a machine learning system as a designer, it's good to sort of roughly know what you're dealing with. So I would like to start essentially with what machine learning actually is. And I think there's lots of terms often thrown around, so it's good to get some clarity on this. First of all, machine learning as such is actually a subfield of artificial intelligence, of AI. Artificial intelligence is really broad, and it's hard to actually exactly define what it is, but it's roughly dealing with sort of all sort of concepts and ideas that result in programs that at least give some sort of that somewhat seem intelligent and are of course created artificially. But then artificial intelligence has multiple subdisciplines. One quite famous one is planning. It's often used in autonomous driving, for example. It plays an important role there if you want to, how do you get from A to B in the fastest way possible? How do you plan a takeover maneuver? So that is also considered artificial intelligence, but not machine learning. Logic also plays an important role. That would be another one. There you would, especially automating certain inference procedures. If you have some inputs, can you automatically derive certain conclusions? And that would be covered by that. But then, of course, machine learning. At the moment, certainly one of the most famous, or the most famous discipline here, where the goal is to actually recognize patterns. So recognize patterns and learn from data. And that is what makes machine learning special and distinguishes it from the other subdisciplines. Okay, now the first question, of course, is how does it work? I said before, like, it's basically about pattern recognition. And one of the, I think, most famous examples is image classification. So you have an image showing something, and then you want to come up with you want to develop a machine learning model that if you put the image into that model, it gives you the classification of that image. For example, saying, okay, that image shows a dog. Now the question is, why do we need machine learning for that? What makes this task fundamentally different from all the other tasks that we can just solve using normal programming? And when we think about it, normal programming, basically how a programmer thinks in a way in terms of if-then statements, right? They say, if this happens, then I do this. And that's sort of how most of these traditional programs are built. Now, how would you want to do that with an image when you want to do image classification? Well, we humans, for us, that's super easy. We can sort of see some of the features. We see, well, there's a dog nose. That makes it more likely that this is an image of a dog. So you could think, well, a programmer could approach it in the same way. You could say, well, okay, this pixel here is black, and then the pixel next to it is maybe black but slightly lighter, and then the 100 pixels around it also have this very special shape and this very special colors. Then this is a dog nose. And well, you could kind of do this, but then you would have covered only one specific case. Of course, there is trillions of different dog noses that could appear in pictures. They could appear in different places, different rotations, different colors. So it's just impossible to cover all of the possibilities using sort of that normal paradigm of if-then. And this is where pattern recognition comes in. Instead of sort of programming this manually using as a programmer, we want to come up with a machine learning model that then does that work for us. That could sort of extract certain heuristics automatically, finds good representations, and then gives us the answers that we want, makes these predictions that we need. Okay, so let's look a bit inside what is actually going on inside the machine learning model. As always, you have this. You have an input. So this is actually something that you might be dealing with as a designer as well when you interface a machine learning model. You put something into the model, and then you get an output. For example, you put the image in, and you get the classification out. Now, inside, Machine learning model, there's lots of numbers. Of course, you can't have machine learning without all the math. I'm not going into detail here, I'm just giving an intuition. One way of thinking about it is that it's sort of a machine with lots of parameters, with lots of knobs that you can turn. I think many of you might say, remember sort of the radios, and I submit I'm also not too familiar with them anymore. I'm a bit too young for this, but yeah, there's these radios where you have to adjust the frequency to get sort of a crisp audio signal out of it. And you can think of this of a machine learning model in a similar way, right? You have not just one knob, but you have literally billions of them in big models. But the idea is similar. You put something in, radio frequencies, you could say, and you get something else, the audio signal, but you have to adjust the knobs such that sort of you get the desired output. And this is what we do with the machine learning model as well. We sort of tune these parameters until we get the right behavior when it comes to putting something in and getting the right answer out. Now, how does that work? Essentially, let's go through the example with image classification. We start with sort of a random position of all the knobs. So, of course, those are not actual knobs; they're just parameters. We initialize, we set them to sort of random values. Just doesn't matter actually, just some random positions. And then we put the image in. So that's our first image. And for these sets of images that we're dealing with now, this is the so-called training phase because we're currently sort of teaching the model what to do. For these images, we know the right answer. So we know that this one's a dog. Someone has labeled those images before. Now what we do is we put that image into our model, and because we've already randomly set these knobs, we get some output. Now that output could be horribly wrong. In fact, most likely will be horribly wrong because we just randomly initialize that model. So it might say, well, that's a cat. And that's, of course, we want to fix that. So we want to kind of tune these knobs now to give us a better answer. And well, with the radio, you probably do this kind of by sound. You just try one direction, try the other direction, and see whether you can find the right frequency. Luckily, with machine learning models, we don't have to do that. That would be quite cumbersome because you would have to do that for billions of parameters. So instead, we can use an algorithm. Doesn't matter how exactly it works, but what the algorithm does is it tells us how we need to adjust these knobs. It's called the backpropagation algorithm. Maybe you've heard of that before. Essentially, it just tells us, well, this knob you have to adjust by 0.03, this one by minus 0.24, this one by 0.16. Might seem a bit arbitrary, but yeah, the algorithm tells us what to do. And then we change these, and now hopefully our model gives us a better answer and actually says, yeah, that's a dog. Now, it worked maybe well for this image, but we of course wanted to work for all possible, for many images, ideally for all possible images of dogs and cats. Now let's try this again. Maybe we take another sample, put it into our model, and maybe by chance, it gives us the right answer, so we don't need to do anything. We don't have to adjust the parameters. Next one, another image of a cat. Maybe we're unlucky this time, and it gives us a dog. It gives us a dog as answer again. Now, same thing again. We run our algorithm that tells us how we need to adjust these radio knobs, and then you adjust the parameters, and you hope that you get the right answer. Okay, so this is sort of the training procedure of how you do this. And this replaces that sort of step of where the programmer goes through sort of devises an algorithm, writes the code. Instead, we can do this with this algorithm. And that's sort of the power of machine learning, because we can therefore, if we have data, we can easily recognize patterns in that. Now, I sort of talked about machine learning models so far. One particular type of machine learning model, and probably the most famous one, neural networks. You probably have heard of them before. They're very famous at the moment. And yeah, they're indeed incredibly powerful. What does it mean to use a neural network? It's essentially a specific type of model where the neural network sort of tells us, if we know that we're using a neural network, then this tells us the structure of the model. It sort of tells us how these knobs are connected, how they affect each other, and how they affect the output. So the structure is defined by the type of the model. Here you can sort of see the standard visualization of a neural network. It is essentially these, it looks like it's this graph structure. loosely sort of resembles an actual natural neural network that we all have in our brain. That's also where the name comes from. And so why is this interesting for design and for behavior? Well, essentially, as we've heard before, behavior is also can be sort of collected. Information about behavior can be collected, and that is then data as well. And it would be surprising if that data didn't also contain patterns, right? So we can collect that data and train a machine learning model with that, for example, a neural network, and have various prediction tasks. We can make recommendations. We can, for example, recognize spam. That would be also one possible task. But yeah, but just lots of possibilities that we have with machine learning and that we might want to consider in design and when it comes to user behavior. Now, before we move on, I would like to address some of the sort of the trends, because that leads us to where we are today. The sort of the trends in machine learning. The most well-known one certainly is going deeper, and that has led to this keyword deep learning. Just to give you an idea of what that means, essentially means that we have more complicated neural networks. So you've seen the structure before. Now we just have a more complicated, so-called deeper neural network with more layers of network. That means we can solve more complex tasks. Nowadays, it's sort of feasible to have a neural network that doesn't just classify cats and dogs, but it classifies thousands of categories. In fact, if you have a phone, you probably realize you can search your photos with text now. So what happens is they're classifying all of your photos, they're looking what's on the photo, and then you can search using text. So that's already running on your phone, basically. So that's how far we've come. Of course, it's computationally more demanding, and that has been the bottleneck in the past, but sort of in the last 10 years, we've seen a huge increase in computational power, especially with GPU machines or specialized hardware that has helped us train bigger models and therefore address more complex tasks. And another trend in machine learning, the second one that I'm very excited about, because this is also what my research is concerned with, is structure in machine learning. This might sound a bit abstract, but structure essentially means that our data, there's some structure to our data. And here's some examples. So there is truly unstructured data that is just a collection of numbers, and you try to sort of make sense of that somehow. So the simplest form. But then there's other types of data. There's image data, which we've seen before. And there's the structure here is that you have this grid, and you have these pixels, these color dots on that grid. And when we know that our data always has that structure, then we can sort of improve our model. We can sort of adapt it to that specific task. And that leads to better accuracy in our predictions. There's other types of data. Sequence data is quite common. For example, when you have a time series, like a stock chart, that would typically be sequence data, because you have that it sort of changes over time, so you know it always goes forward. And then the one that is the most recent one, and a very exciting topic, is graph data. So graph data meaning you have these nodes and they're connected by edges, and that's a data structure that can model so many real-world scenarios. It's an incredibly powerful data structure. For example, social networks can be modeled with this. So if you have a project or a product where when you want to make recommendations in a social network, and you see some of that, then you're basically dealing with graph data. And this is exactly what I would like to hand over to Emanuele, because he will be talking about how exactly we can use graph data and machine learning, combine that, and see how we can make recommendations and essentially use user behavior to improve design of the product. Thank you.
Thank you, Felix, for handing it over to me. Waiting for the slides. Okay, yeah, it's already my screen. Good, yeah. So thanks very much, Felix, and also thanks for introducing some of the basics of machine learning. And I'm going to build on these basics to talk about an application of machine learning, which is recommender systems. And the reason why recommender systems are so interesting in this context is that they are one of the key models that are interested in capturing user behavior. But first of all, you may be wondering what actually are recommender systems. So recommender systems are basically the main engine that powers some of the most important websites that we have, right? So from Netflix to Twitter, Facebook, Instagram, what is in common between all these services is that they have a very clear question of, what are we gonna show our users? We have a lot of content. This content can be movies in the case of Netflix, or posts in the case of Instagram, Twitter, Facebook, or products for Amazon and songs for Spotify. And we really need, so there are a huge ton of them. So we have millions or billions of pieces of content, and we need to choose a few of them to show to each user. And this is critical for their business. You could think of heuristics to solve this problem. So probably the most simple heuristic would be, let's say in the case of Netflix, you can say, I'm gonna take the most popular movies, in the world, and I'm just gonna recommend the same most popular movies to all users. Clearly, you can, see that it's not optimal, especially because it's not personalized at all. So everybody's seeing the same thing, and it's not maximizing, the interest of either the company or the users. And this basically brings us to the idea that we really need machine learning for recommender system. And we need machine learning to basically understand user behavior. And given this understanding, this would allow us to predict future user behavior. And by this prediction, we can actually decide what to show to users, what to recommend to users. So as a more practical example, I'd like to start with the Netflix prize. So this was a challenge that was actually introduced by Netflix in 2006, and was, it could be seen as the birth of recommender systems and the field of recommender systems. So Netflix basically open sourced this data set from their data and set up a challenge. So basically they asked, the world, please come up with a better model, a better algorithm to recommend movies to users. So if we look a little bit at what this looks like, you can think of it as a table. On one side, here we have all the users, and here we have all the movies. And then some of these entries are filled when a user gave a rating to a particular movie, and some are not. And the goal is basically to fill this table. So we would like to predict the rating a user would give to all users would give to all movies. And by intuition, you would think you would like to model to do something like noticing patterns. For instance, here we see that both Jack and Oscar give. So this is a super simple example, but basically both Jack and Oscar give quite a high rating to both Django and Inglourious Basterds, and Jack gives a low rating to Fast and Furious. So from here we can kind of maybe assume that Oscar and Jack have similar taste, and so we would expect Oscar to also give a low rating to Fast and Furious. Clearly, these would be with millions of users and millions of movies, and this table would be very sparse. So it's a very hard problem, and the goal is to use machine learning to basically fill this table and make predictions, as good as possible. The use case is clear. So once you have the ratings, then you can basically just suggest to the user the movies with the top ratings. What is interesting is that in this competition, the only information that Netflix released was the ratings itself. So we didn't know anything about the users apart from, we had some user IDs, but there was no information attached to them. And also we didn't know anything about the movies. Of course, we could go somewhere else and get information about movies, but not in the data itself. So it was not part of the competition. And this was already 2006. So even heuristics were tried and many models. And usually when you only have ratings, the type of models that are used for this are called collaborative filtering. However, what if we also have additional information about user and movies? So as I said, here we only have the ratings, but you could very well think that in many practical scenarios, you have Jack, but you also have, how old Jack is and where he lives, what languages maybe he speaks, and also something about the movies. So how long the movie is, in what language it was screened, and also maybe who was the director, and so on. So it will be interesting to be able to incorporate seamlessly this kind of information to make better prediction. And this is where deep learning really came in to recommend the systems. So deep learning is very good at making use of features. So here you can imagine your input to your deep learning model is 2 vectors. So one represents information about the user, in this case Jack. One represents information about the movie, in this case Django. You feed this into your machine learning model, it does its magic and makes a prediction. And in this case, it will be the rating. And this model will be trained on the data that we observe, so these numbers here, and we would use it to predict what's unobserved, so the question marks. Going to a more recent example, which builds on this. So yeah, maybe didn't mention, but the Netflix challenge was started in 2006, so a very long time ago. More recently, actually, this year, Twitter introduced its own challenge, and it contains a lot more, a lot more information and more tasks. So what actually you want to predict was what tweets a user would like, but also reply to or retweet. So if we think about this in terms of a model, you would get the input would consist of user information. And so, for instance, information such as how many followers the user has, how many people the user follows, and other similar information. We also have information about the tweet itself. So, for instance, the text of the tweet. We also have information about the author of the tweet, since this, can be seen as, part of the tweet itself. And this information will be similar to what we have for the user. And there is also an additional single feature telling us what type of interaction this is. So as we said, could be a like, could be a reply, or could be a retweet. And this all goes into our model. And in this case, we want to predict the probability of an interaction. So what is the probability that this user would interact with this tweet, with this specific interaction here? So we have seen, moving from ratings in this case, and then adding features, and then maybe different types of interactions. A very nice way to think about these kind of problems is actually thinking about graphs. So Felix already mentioned that graphs are started to gain some importance in machine learning, and here also recommended system can be very nicely modeled as a graph. So this probably would have been nicer. I was planning to share my iPad and draw this live, but it didn't really work out, so I had to pre-draw it, and so it's a bit cluttered. But if we just first focus on the black edges, so on this side we have user nodes. So each circle here, it's a user, and so we have user 1, user 2, and so on. And basically on this other side we have tweets, tweet 1 to 4. And here we can draw an edge each time a user interacts with a tweet. So for simplicity, let's say we only care about likes here. So from here, from these edges, we can see that user 1 has liked tweet 1 and also tweet 2. We can see that user 2 has liked tweet 2 and tweet 4, and so on. And these already consist of a graph. When we start thinking about this problem in this form with a graph, what is very interesting is that we can actually add other graphs to this kind of information. So for instance, these purple edges that you see here actually come from the follow graph. So the follow graph is literally, who follows each other. And so from here, you could basically say that U1 follows U2, or vice versa, that U2 follows U4, and so on. And you can see that also this information that, it was not present, for instance, here. We have no idea what's the relationship between Jack and Oscar, but also here, this information is not contained. But it can be very useful in our task. So you could think that if a user follows another user, they are more likely to like the same type of content. And so this could inform me on which tweet one of them may like. And basically, yeah, I didn't mention it, but the task again would be, this red edge here, which basically is saying, is there an interaction between user 3 and tweet 4? And I wanted to be able to predict this given the graph information, and also I drew here some what would be some vectors, which are the features, the same features that, for instance, we had here. So this is just a different way to think about the problem as a graph, and it also allows us to seamlessly add additional graph information that it was not clear how to add this here or how to add this here. So now that we have a graph, you may wonder, okay, what do we do with a graph? And luckily, we can use graph neural networks. So graph neural networks are a new class of models which have been introduced 4 or 5 years ago. And the idea is that they allow you to do machine learning on graphs. Usually when you think about machine learning, the very popular success stories are about images or about text, right? So we are able to classify images into classes. We're able to do on text to do, for instance, sentiment analysis or even text generation. However, many pieces of data in the world are very well represented as graphs. So recommender system is one, but you could also think of molecules are very naturally represented as graph. And graph neural network are basically able to take as input a graph and making use of both the connectivity of the graph, so the graph structure, as well as features information. So features, again, are, would be on each node, for instance, these vectors that we have here. They're able to make a prediction. And the advantage is that they can use both these sources of information, and so they can make usually better prediction than using either source independently. So after having seen this more recent model, I also want to give you another more practical example, also coming a bit more related to what I do. So there are many obvious recommender system examples at Twitter. So for instance, recommending, deciding which tweets we're going to show you in your timeline. But there are also less obvious examples like this one. So basically, what I'm showing here is what happens when you go to somebody's profile, in this case, Biden. When you follow that user, immediately after you follow the user, you get recommended here, you get suggested 3 other profiles, with the idea being that we want these profiles to be similar to the user you just followed. And hoping that you are also interested in these profiles and you will follow them as well. So here you can clearly see that hopefully these 3 profiles are quite well related to Joe Biden. And clearly, you can think about some heuristics to do this, but the best way is clearly using machine learning. So using all the data that Twitter has about previous follow event, so who followed who, we can really learn who to recommend you here. So we're using machine learning to do this, and now we're actually trying to use graph machine learning to even improve over this. So after this application, I will also quickly like to mention some new frontiers. So already, as I mentioned, graph neural networks are quite recent, so probably like 5 years old. But some of the new frontiers in this domain actually involve what are called dynamic graphs. So if we look at this graph again, the information it contains is about nodes and edges, but it's a static graph, so it's given and it doesn't change. However, many times in real application, the graph is constantly evolving. So for instance, in Twitter, in Twitter, this happens all the time. So the graph is never static, but it just changes continuously over time. And so, and very often this, the evolution over time, the dynamic of how the graph changes is fundamental to make predictions. And surprisingly, there hasn't been that much research involving, how graphs change over time. And so this is what actually I'm mostly focusing on right now. So here, just to give you a bit more of a concrete example, again, is that this will be, something similar to Twitter, a simplified version of Twitter, but you have users which follow each other at specific timestamps. So for instance, these are the user at timestamp 50.2. And also all interactions between user and tweets. So for instance, we see that this user retweeted this tweet at time 22.3. And given all this information, we want to be able to make prediction for specific timestamps. So we will be asking the question, okay, is this user gonna follow this other user at time t100? So maybe I don't care, about right now, maybe I care about the future. So this also allows me to very nicely predict that. And we can also make the same kind of prediction whether a user will like a tweet, in a minute, in an hour, or in the next day. And this really allows us to use both features on the tweets and on the users, both the connectivity, so the graph information, and also the temporal evolution. And combining these three pieces of information leads to better performance than using any of them individually. So just a quick summary and some key takeaways from my talk. So we've seen our recommender systems power some of the most important websites, and basically they choose which content or products to show user. We're also seeing that machine learning is the most successful approach to recommender systems, and at the same time, graphs are a useful framework to represent recommender system recommendation problems. Luckily, we have graph neural networks, which they enable to do machine learning on graphs. And so we are able to solve these problems using this tool. And we also see now dynamic graphs are one of the new frontiers of graph neural networks, and the focus is really on the evolution of the graph over time. So I would close it here, and I think we are in time to take questions. Carlo, I think you are muted. Yeah.
Yeah, I did it again. Awesome. So it doesn't look like there are questions for you guys yet. So we probably want to move further with the rest of the presentation.
Sure.
I think it's Andreas, right?
Yeah.
Okay, perfect.
Can you hear me properly?
Yeah, I do. And let me add you from the stream. And okay, the stage is all yours.
Fantastic. All right, guys. Good evening. I think it's late for most of you. I assume that all of you are connecting from Europe. In case there are some American friends, well, good afternoon. I don't think there are any Asians because they sleep at this time. So the first part of the presentation was about what I call good behaviors, and we're going to talk about bad behaviors. So we're going to move more into the cybersecurity domain and how behavioral analytics is reshaping sort of a gray but relevant word. So first of all, you know about Gartner. Gartner has defined it 2021, and I think even beyond that, it's going to be the Internet of Behaviors. And so in a way, what Felix and Emanuele explained on recommendation system and stuff like that is, I mean, behavior or technology for detecting behaviors is going to be melted, infused into many technologies. So let's talk about security. And as I said, So to get it started, I always use one of my favorite movies, also as homage to Sergio Leone, the famous director in Rome. So we spoke about the good behaviors. Now we talk about the bad guys, okay? And so in the next 10 to 15 minutes, I'll tell you how cybersecurity is changing using behavior analytics. And I think more importantly, I'll tell you the way you should use these data when you design user experiences. So first of all, there is an old view on cybersecurity, which we call it old. The reality is it's still very actual. It's still very current in many companies. So the old view or the stereotype is that the bad guys are outside of the fort and the good guys are inside the fort. So the question is, really? Do you think that's the case? No, as you can imagine, there is a different harsh reality. The harsh reality is that the majority, some research say over 60% of the security threats are coming from either insiders, meaning employees, contractors, anyone with an IT access to business application inside a company, or with a collaboration coming from an insider. So before we talk about this 60% internals, let's have a look at what the bad guys are doing in the so-called 40%. And this is a bit of basics around security. You might have heard about phishing, spoofing. In simple terms, they're trying to fool you so that you can concede or give away credentials without being aware about it in any possible way, okay? And as you will see later on, this is very important because this is a way to become unconsciously an insider or a collaborator to a crime perpetrator. Another very common activity, especially in I would say in the last years, is ransomware. So you block an entire database, archive, and you ask for money, typically cryptocurrencies, to unblock it and to restore your data. So if you have a backup which is 2 days old, maybe you might restore a backup. Otherwise, you simply pay. And it ranges from few dollars to several $1,000 or several hundreds of thousands of dollars, depending on the understanding of the hacker about the relevance of the data that they are encrypting. But let's go back to the insiders, okay? Because this is really where most of the user behavior analytics comes into place. So as we said, insiders are very often partner in crime. Sometimes they do it consciously. Consciously meaning someone is acting in a fraudulent way and they use their access to data for extracting some data, or sometimes they just sell their credentials. There was a research a few years ago, US-centric, that was revealing, astonishingly, that employees were giving away their user and their password to the Active Directory domain for a few bucks, okay? Probably the price went higher, but still that problem is there, so consciously. Now, there is also the unconsciously being part of partner in crime, and this comes specifically as a result of a phishing attack, where they store your credentials and you don't know that. You are a very well-behaving employee, but someone is using your access to do other stuff. So it's very important every time to understand behaviors in order to detect suspicious changes, or as we call them, anomalies. So this is a nice article that you can browse in the internet, and it's a year ago. This guy came out with a nice article on Forbes and said that basically cybersecurity requires a different approach, okay? Moving from indicator of compromise to indicators of behavior. Let me explain what these mean. In the old days of security, and in a simple term, even today, if you're using old software, cybersecurity products are detecting the footprints. So if it's a deer footprint, maybe there is nothing to worry about. if it's a wolf footprint, then maybe there is something to worry about. But as you can imagine, that doesn't mean much. And a bunch of this footprint detection was based on rules. That means programming. You have to code and define every specific situation that you want to detect. You can imagine, super complex. That tomorrow, this is what we do at Sherlock as a company, but that's a tomorrow for many companies in security. You detect anomalies on individual users based on their individual behaviors, okay? And that's very important. So it's not a rule, it's a variation upon the baseline, pretty much as the mother and the father do when they watch their son's eye and they say, well, was it good at school? Well, he says, yeah, it's fine, but the reality, his or her eyes are telling a different story. So behavior detection. And this stuff, there's no way to build behavior analytics other than using machine learning in all the possible forms, including graph-based. Let me give you a very simple example of why or what you can do with behavior analytics that it couldn't be done in the old way of doing. I call it behavior analytics versus the use of rules. And it's a very simple one. But in the old school of security, the rule said every time that a user has 2 failed consecutive logins, raise an alert. Reality being a bunch of false positives or false positives like.
Sorry to interrupt you, but it looks like your presentation is stuck on the second slide. So,
which one?
Your presentation, your screen, it looks like it's stuck on slide 2. I'm not sure it's intended, so I just wanted to notify you.
It's definitely not intended. So is it getting better now?
Yeah, it's moving. We are on slide 8 right now, so just
all right. So good. It looked like the projection didn't really work properly. So let me start from here, okay? So you might have heard a bit of that. So as I said, what products today, most of the products are doing, it's still today they are detecting footprints. The tomorrow is detecting anomalies based on behaviors. And if I move to the slide that I was presenting upon, it's a very simple example of what you can do with behavior analytics versus rules. Please confirm that you are seeing my slide, even if not in presentation mode. Is it okay now?
Yes.
Good. So the old school is you define a rule that says every time a user has 2 consecutive failed logins, then raise an alert, do something, because looks like might be someone trying to use your credential or abusing it. The new behavioral school is totally different and says raise an alert every time a user has a significant deviation upon his baseline. Why is this relevant? Because Carlo is very login savvy, and if he fails 1 login per month, that's even too much. I usually fail it twice every week or every day. So my baseline is significantly different compared to his. So that's why behavior analytics is reshaping security with a very simple goal: to create less false positives. Now, one of the, I would say, additional guiding principles of the new school of security is using Agatha Christie statement. 1 coincidence is just a coincidence, 2 are a clue, 3 are a proof. So that's what I call old school is good school, because in cybersecurity, you need multiple clues, multiple anomalies, so to be able to predict a threat. Because one of the mantra is really about to avoid false positives, because companies cannot really manage thousands of security incidents. They need to focus on the real ones. So the name of the game for us in security, it's really accuracy and maximize the reduction of false positives. So this is a very Agatha-inspired behavior analytics. So if you have a user with a number of anomalies, and the anomaly typically has unusual inside it, So if you have logins from unusual locations, an unusual exchange of emails, I mean, more emails than ever. If you have unusual sequence when you access an application, the example here is also Salesforce, or if you're working with the unusual working time, even during the pandemic period, then probably the combination of all these anomalies are making the company to suspecting that you are trying to commit a fraud. And the example here is this sales guy might be changing the shipping address of some goods that were previously purchased for a different client. Now, behind the scene of these tooling, there are a number of machine learning models with a relevant and increasing level of sophistication, but the bottom line is built on two pillars. Ability to spot a lot of anomalies and to filter them out based on peer analysis. It's very important to filter out the commonalities, because if 100 users belonging to the same user department are all doing the same anomaly, it's probably an organizational change. It's not a security threat. Security typically relates to few people doing very exceptional things. Now, I'm moving really towards the end of it. So the goal was really to give you a bit of a taste of what's happening in cybersecurity and how behavioral analytics is really reshaping the efficiency and the resilience of these tools. So now the question is, you should be all designers or working in design space, and you typically think with a very, I would say, reasonable mentality, which is my user experience, my design has to be nice and with good taste. Now think it differently. If you take these data and you get an input which tells you this user, which is currently accessing your beautiful interface, is potentially not the guy that you think he or she is, what can you do? So up to now, today, not much. I mean, we simply block access to the application, but I think in the future, you designer can make the application unfriendly. So I think that I think it's familiar in the world of design, but I think an unfriendly design, so to protect the data in risky situation, it's becoming relevant. 3 examples here, okay, in increasing order of sophistication. So first thing, you could be, say that you have a user your application, and you receive a signal that says, well, risky guy. Maybe this guy is accessing very relevant commercial information. You obfuscate the data. So it's still there, but the interface is blurring. Or you can stop providing that data and you just require additional validations, okay? Could be a selfie, could be using some streaming system that are validating the real identity behind it. But I think that's an idea that came to me when I was preparing this chart, is like in the old days where cities were built with a maze inside so that the enemies could easily get lost when trying to invade someone. Well, even the user experience can get mazification. In other words, the path to obtain the data becomes increasingly more sophisticated and complex. So if that user is a well-known legit employee, he will make his way through the data. But if the guy is someone just trying to access data in an easy way, maybe he or she would get lost. So I think that in the world of design, what we can do for you designers coming from a security space is to give you signals and about a risky situation. And I think you have the ability to manage design, so to make it a little unfriendly. That is it. And apologies for the lack of presentation mode, but I think it went well anyway.
It did. We actually collected a couple of questions, 3 to be precise, but probably more are coming. This discussion to take off. I want to just add a comment to underline what you said about why it does matter for us designers, because there are a couple of examples that actually happened to me, and it's very important to understand what is going on. For instance, talking about authority of a system, there's a lot of talks about being friendly in the UX writing. So in the way you do express yourself in a written way in order to get people engaged. And this should be the next big thing. It is already and stuff like that. I just want to underline that it actually depends on when in the customer journey people are and how you want to be friendly and why. Just think of the recovery password page of any digital service, right? So probably you panicked already. When you reach that page, if it's an important service, you panicked because you don't remember the password. Probably the password is still ABC123 as the most common pattern usual user have for their security. It doesn't matter, but probably he panicked or she panicked about that. So why should we be very friendly or a little bit, joking in that kind of page? We need to adopt the right tone of voice, but at the same time, without understanding the threats that users faces when there are in certain scenarios and in certain stages of a customer journey, well, we cannot apply the right tone of voice in the right way. At the same time, if we don't understand how a machine learning model work and how we could make it, working for the user, how can actually design a better, sorry about that, a better way to, get them on board. So why we're talking about that, probably some of you asked if you are designers, is that if you don't control what is the system, what is going on in the system, according also to Nielsen heuristics, how would you manage to design something that is really effective for our user? So I just wanted to give it a little bit of a context in terms of design-wise, because I think it's crucial, since I opened my presentation today talking of the orchestration we need to do as designers, that we understand every single aspect. I mean, I'm not talking to be fluent in every matter that it's involved in a complex project, because it's impossible, and probably you wouldn't do that anyway. But on the other hand, I'm talking about at least understanding what is going on and knowing what question you could pose to users, to stakeholders working with you in the project. So, getting back to questions, I can read, and you guys raise up your hands. I'm gonna put you on the presentation all together so we can actually answer. The first question that I have, I just removed Andrea, sorry for that. The first question is how to choose the correct machine learning model?
Yeah, I think I can answer that. Essentially, that's a really tricky task, and is basically the job of machine learning engineers. It's not something that is automated just yet. There's multiple considerations well, there's multiple factors that need to be considered. One of them is, as we mentioned in the presentation, is the structure of the data. So if my data naturally is well described by an image, then I would use a model that is suitable for that. So there's the so-called convolutional neural networks. They work well on images. That's one example. If my data is well described by a graph, then I would choose a graph network. So then I choose this particular type of model. There's other considerations as well. When it comes to the size of the model, I have to consider how much data I have, how much compute power I have. How quickly do I need a prediction? So there's really lots of factors to consider, and that's kind of the art and the science that machine learning engineers are good at.
Muted.
Yeah. Thanks a lot, Felix. I did the muting thing. I need to learn how to do that at some point. So the next question, I think, would be towards Manuel, but you tell me who's better. Talking about graph neural networks. There is some changes on the typical structure of a neural network and hyperparameters.
Yes, so basically to allow these models to operate on graphs, there needs to be specific changes. In particular, the underlying maths changes a little bit. They are overall inspired from convolutional neural networks, which are the models that operate on images, but they are different. So yeah, there is underlying changes in the math of the model. However, if you think of it as it's still in the same pattern of a model that takes an input and gives you an output and what's inside the model clearly changes. Regarding hyperparameters, yes, maybe like you have some different hyperparameters, but that doesn't really you would select them in the same way you do with other kind of data models, so that is not too specific.
Probably you already covered that in your presentation, but maybe someone jumped in the webinar right here, right now. So would you mind to just sum up quickly what a hyperparameter is for people listening?
Yeah, sure. Yeah, good point. So basically, in machine learning, you have parameters and hyperparameters, which are very similar name, and they are similar things, but not exactly the same. So parameters are the numbers that make up your function. So Felix was saying that basically a machine learning model is a function, and we want to learn this function. When we say we want to learn a function, actually we're learning the parameters. And these parameters, let's say, are numbers that describe the function. And these can be learned. We have very good ways for learning them from the data. Whereas hyperparameters are similar to parameters, but they are a bit more abstract. So, for instance, if you have a neural network, the parameter itself are the weights of these neural networks, so the numbers that describe the neural network, and an hyperparameter would be how many layers you have in the neural network. So, for instance, the number, how deep the neural network is. And this is not something you can learn directly the same way as you learn parameters. So you just need to be a bit careful on how to select this, but they are quite similar.
Okay, perfect. So thank you so much, Manuela. I think we have another last question we collected for now, but I have one for you later, which is how can you measure the reliability of a software site and so on?
I can take that one.
Yep.
Can you hear me? Am I on mute?
Yes. Yeah. No. That is me. I'm the muted guy, so go on.
You're the mute guy. You're the mute button guy. So that's a very good question, because we didn't cover, the presentation was about security and users. The reality is that if you switch user and behaviors, and you put a server, an application, and you have sensors of now that application runs, anomaly detection works also for detecting changes of reliability of a website, of an application, or a database. So we are using the same technology or the same approach for different use cases. So one is exactly measuring the reliability of a software site or in general IT service. But think also the productivity part of an employee. Okay, this is something which is a bit tricky, especially for Europe with our privacy regulation, but there is nothing preventing the ability to detect a sudden change of behavior in terms of activity. So all of a sudden, you went remote from home and your usual activity decreased on an average by 30%. So there are other domains or use cases where security behavior analytics can be used for, and measuring the reliability or anomaly detection on the software side. It's one of those applicability domains. Then there are a bunch of evil details, so that we sell ourselves into the market. We don't try as security vendors not to be too generic, but the underlying technology can well address this problem as well.
Okay. Okay, perfect. So, fun. I've seen that while we are talking on the comments of the back office of this application, we've been attacked by a spammer, which is hilarious in a way. We have some nice comments into the back office, but just to give you our contextual is right here, right now, to this topic anyway. I had a question for you guys, but I actually forgot it. So, my point would be, how you think, oh yeah, what is, as a machine learning and neural networks and security experts, what are the opportunities they're actually missing or not exploited enough or taken advantage of, in this case, by the other stakeholders you're working with? Like, you would see designers or business analysts or whatever pursuing this or that way, if there are any, of course.
It's maybe a very open-ended.
Yeah. So, what is the question? What are the opportunities to use for applications of machine learning and security?
I mean, my curiosity would be: do you have any missed opportunities or interesting path that it's not still walked through enough, and you would see it more taken advantage of?
Well, maybe I can take that one. And my advice would be to designers, and I talk about software designers or designers of anything which is able to produce a log file. If you are in control of that, try to release very content-rich log file, because if you provide a lot of data, you get a lot of data back. And I've been in the market for many years, and historically, application designers, not designers, but the guys who design the back end of applications, were very tight in releasing rich amount of data when it came to log file. And now they're suffering because they can't really provide data so to have anomaly detection. So you as designer should be very firmly positioned to say, no, if you have a developer, back-end developer who's working with you, ask him to create very rich log files, because you're going to benefit from that in the longer run.
So we should use the -v option to talk nerdish, like verbose logs or something like that, in order to give you more details to work with.
Yeah, we live with data. We live on data, so the more the better.
Yeah, I have a couple more consideration about that. The first is, do you think that you're gonna shrink the amount of time needed to go to collection of data, to Shazam of COVID, I mentioned in a previous call with you, in the next few months or years? Because as far as I've seen, but maybe I'm wrong because I'm not in the in the field. The MIT started collecting data since the pandemic started, and then they released the application with a very good confidence, interval confidence of prediction like 1 week ago. So it's been quite a few months of training and collecting data and stuff like that. Do you think it's gonna shrink? How much it's gonna shrink and when? It's gonna be like, I'm not saying real time because it's not gonna be, but you see my point. That's like the revenue for people.
Yeah, maybe I can say, I think it's gonna, I can't of course give like an exact number of days it will take in the future, but it's definitely gonna shrink because people in industries are gonna get more familiar with the needs and the requirements for training and running these models. So we see that there will probably be infrastructure available to quickly develop a model given sort of the circumstances of the task, and then run the training on servers that are already available and have that compute power, and then make these predictions and make it available to people. So I think because the whole field and the whole industry is maturing and it's sort of getting more, acquiring more knowledge about how machine learning works and how to make it work in practice. I think we'll definitely see that in the next years, this time will drastically shrink.
Okay. I don't think there are any other collective questions, so I'm going on with my own curiosity. Just shoot me in the face if it's too much or if it's not appropriate. You were saying we need to, produce more data in terms of log files and stuff like that. Can you see any data pollution coming over? Like this amount of data produced, even though it doesn't take so much space or stuff, is it gonna be some kind of topic in the near future? This data deluge or pollution coming over?
Well, first of all, to train a machine learning model, you don't need to keep the raw data. You just use them and trash them. Okay, and I think that most of us are doing that way. We are very sensible when it comes to storing data that might have a personal information relevance. So that's from the perspective of machine learning. You don't need to store that. So you compute them and you trash them away. Still, if you have to store them, I think that storage is no longer an issue. It's virtually unlimited. I don't think that's.
That is not
I don't think it has a price effect any longer. It's so bloody cheap.
No, that is true. It's very cheap.
Yeah. If I can add on that, I also see. Yeah, I think there's basically no price for now. We can have terabytes and petabytes of storage, which doesn't cost that much. I think now the main concern is about really the privacy of the data, because like 10 years ago, you could do like machine learning was using any kind of data without any, nobody worried about privacy, so you didn't need any kind of consent, and you could keep the data forever. Whereas now we're seeing a big shift towards privacy. So I mean GDPR, and that also affects machine learning because it basically says that you can't keep data forever. So if you're Twitter and somebody deletes the account, you need to get rid of all the data, right? And that also creates issues for machine learning in the sense that you need to take this into account. And so this also created a lot of new avenues on how to do privacy preserving machine learning. So maybe even making sure having some guarantees that your model is not infringing the privacy of the data set, and I think it's getting a lot of traction. So maybe even there is research on training models on encrypted data. So basically, you're saying Or yeah, this is one, so in encrypted data, or the other one is also what is called federated learning, especially on medical applications where you say, okay, I don't want to give my data to anybody, but I'm happy if it just stays on my phone, so it doesn't go to any cloud or anything. It just stays on my phone, but I allow for somebody with a model to come to my phone. The model looks at my data and then just sends back to the cloud, some update to the model. So the cloud never sees the data, but is only able to train it remotely. But the data never leaves my phone. And these areas are getting a lot of traction. So I think privacy is becoming a big part of machine learning.
Yeah, I mean, my comment about that is that I'm seeing this approach, if I got it correctly, again, I'm not in the field, the way Apple is tackling the, machine learning scape with the on-device computation and so on. Yeah. And while, I mean, the other example that I can have is Alexa with Amazon doing every calculation and computation on their server. So they need the raw file, the raw audio file to be sent to the server, and then the magic happens, and then you get it back. So, am I right? I mean, these are the two extreme approaches. So everything goes online and gets computed remotely, or everything stays on the device, gets computed on the device, and you just update the model.
Yeah, you can also have an hybrid, but I would say now like 99.9 are still all the data goes to the server, and the model is trained on the server. But yeah, there is definitely a lot of now interest in actually doing what what you mentioned Apple is already doing. Some are already doing, but it's still a very small minority of applications of machine learning. But probably it's going to be more. It's definitely going to become more and more frequent.
Yeah, I mean, my take about that is that I don't believe that I don't want to transform this in a pro or against Apple kind of thing, but I don't believe that Apple became a good company towards the users. But I think that they're actually seeing a very good marketing leverage about that. So they think that this on-device thing is getting a thing actually for users buying their phones. Otherwise, they wouldn't advertise it like one of the key features of the new operating systems. And so probably we designers, as usual, should take a further look at what is going on here in this case, because we are called more and more to design and invent services that actually mix up the real world with voice assistants and whatnot, and the digital world. So this approach is, I mean, the remote one is actually the easiest. We are used to that because it's like client-server application that work. I mean, you have a client, you have a server, the server does the magic and gets you back the result. We're used to that. But still, there's something moving on. And probably we designers, we need to understand a little better what is going on here to also take advantage of what the user's perspective would be. Do you have any other take about that? I mean, any further comments?
No, I think you're right.
Okay, so we don't have any questions right now. It doesn't seem so, at least. So if you guys have some further comments, we can actually go on talking about that. It's really entertaining to me. I mean, I would go on for hours talking about that. I mean, despite our resistance, but probably it's a little late in the night, and we're pretty. Not
dinner
yet
is
because
ready.
I'm in the office, but hopefully in your houses, yes. So.
Yeah, that's beauty. Word from home.
Yeah, I know. That's the beauty and the challenge also. But yeah, guys, if you're fine and you don't have any point to add or a quick maybe we can do a quick wrap up to understand what is the big takeaways in this kind of approach. What do you think? Like 3, 4 bullet points that people would take it and reflect about that from home for the next project.
Well, I think I can get it started. I mean, there is one big takeaway, which is if you're designing stuff, just give it for granted that somewhere in the company you're working for, there is or there will be some behavioral analytics tool. And they will either detect good behaviors, for example, recommendations, or bad behaviors. So give it for granted. And I think that's the key takeaway. Don't assume that this stuff it's science fiction, because it's really becoming. I wouldn't call it bread and butter, but for sure you will see an enormous capability to do user behavior even within the enterprises. Okay, so not just the Twitters, the Google, the Facebook, the Netflix. This is becoming a very doable feature in every utility, insurance, bank, manufacturing company. So it's quite of an interesting work, the one you're facing, dear designers, because a lot of companies are building or reshaping their digital strategy that in many cases mean rebuilding the user experience for their consumer, customer, partner-facing applications. And these guys want it easy. While in the old way, if you were an utility client, you had to eat your own dog food. If you were a business partner of a large telecom, well, you had to consume ugly interfaces. Now, everything has to be nice. And as part of that being nice, it has to be convenient and safe. And that's where we come in with the behavioral detection for the good or for the bad. That's my personal takeaway. So Felix, Emanuele, maybe you can add something.
Yeah, maybe generally I would say it's good in other disciplines to learn about sort of machine learning, and it's because it's becoming so ubiquitous in nowadays, and as designers it will be useful to kind of know what is possible and roughly how it works, and you can integrate that into your workflow, and you can you're just aware of what is out there, and you can see, like, as for example with behavioral analysis, what is possible and what exactly might be suitable for a particular project. So I guess that would be my main takeaway, to sort of be curious about machine learning, because it's going to be very, very important in the future.
Yeah, mine actually, I think, it would be quite simple. Just say that basically recommender systems heavily use machine learning, and they are getting better month after month, year after year, even just because they get to see more data, and also because just the modeling itself improves, and it seems like they are getting really better also at capturing behavior, and I think if this could at the moment brings personalization and understanding user behavior, brings personalization in content, maybe it could also bring personalization in the user experience, a more the different level.
Yeah, we actually did a NAC night last year in PyCampus, partner of ours, about adaptive user interface. So what happens if the user interface itself gets controlled by a machine learning algorithm? How does it make it different, my job, in terms of designing, when I don't control what people see, but a machine learning model does? what are the consequences. There is no much literature about that yet. There are quite a few articles, but not so much. I think it's pretty interesting because, as I was saying in my opening statements, today machines are pretty better than us, taking good performing decision because they can, compare a lot of data, and so they can tell you what works and what not in terms of quantitative decisions. So if this is the case, well, and they control how the user would see an interface, how drastically it would change our job, because we don't control anymore what it's the visual of the user sees. So it's not going to be deterministic anymore, because I don't know actually what Felix are going to see, which is different from Emanuele's, from Andrea, and stuff like that. So this is a pretty interesting, field of maybe experimentation and tinkering. I mean, I'm really into that. Maybe I'm just totally crazy right now, but it's fine. I'm used to that. So that is something I want to pursue in my next few months to tinkering again. And, I'll wrap it up. Thank you guys so much of your time. It's been awesome. Hopefully, we made a little clearer also for designers what is machine learning and what is not, which is also a point because most of us still talks about artificial intelligence as a huge umbrella name, but it's a little bit less significant. Our role in this case with designers is to try to get a clear idea of what's going on. So thank you again, Felix, Emanuele, and Andrea, for your time and your participation. And I will just wrap it up and have a little wrap up later with guys getting back from the workshop. So again, have a great night and see you soon, guys.
Thank you. Bye.
Thank you. Thanks for having us.
Bye bye, everybody.
So, our first day, the World Disability Day, Rome 2020, it's going to an end. We are a little sooner than expected, but it's good news since it's been a very, very heavy day for most of us, and the time we chose according to the community desire was a little different, and we are pretty fried up from a work day right now. But before closing, and thank you again, all the speakers that was here today. So Trond, Nick, Sebastian, Alessandro, and Andrea, Felix, and Emanuele, and also Juan on the other workshop. I want to just add and ask Hannah a little bit of her point of view of today's idea. So, Hannah, would you give me your point?
So the first day of WUDRome has gone. I am truly amazed. You humans like to talk a lot and enjoy some good company, even though in a video call. This first day has been amazing, and I'm very much looking forward to knowing more about your perception of us tomorrow. For now, have a nice evening. See you tomorrow.
Thank you, Hannah, of your contribution, and we're going to learn more about our possession of your machines tomorrow again. So see you tomorrow at 5 p.m. sharp. We're starting with Road Kicking Guild from Microsoft, and then Milaria, and then some other awesome speakers for all the afternoon. So guys, see you tomorrow, and say bye to Rich the Ostrich, and also to everybody who's just following us live right now. So tomorrow is gonna continue on a private stream for people with tickets, and maybe we're gonna have a surprise with some typical Roman dish tomorrow night. So have a good night, and see you.